Again, welcome back to Calculus. In these lectures, we're going to learn how to use derivatives to find the rate of change. We have seen in our previous lectures how derivative is used to determine slope. Also, derivative can be used to determine the rate of change of one variable with respect to another. Example of an applications are population growth rates, production rates, water flow rate, velocity, and acceleration. So a function S that gives the position, which is relative to origin of an object as a function of time t, is called the position function. And the rate is equal to distance by time. So the average velocity, it will be the change in distance divided by change in time, which is dx over dt. And so let's see one example. You have to find the average velocity of a falling object. Here we say a ball is dropped from a height of 100 feet. The ball's height s at a time t is the position function given as s equal to negative 16t squared plus 100. So that's our position function, where again s is measured in feet and t is measured in seconds. Our question says we should find the average velocity over each of the following time interval. So the time interval is between 1 and 2. B will be between 1 to 1.5, and C is between 1 to 1.1. Again, our position function is S equal to negative 16t squared plus 100. So our goal here is to find the average velocity. So here we say to find the interval between 1 and 2, we are going to plug 1 in the position function given to us, which is again negative 16t squared plus 100. So we'll say that s at 1 equal to negative 16 times 1 squared plus 100. And that's what we have here, negative 16, 1 squared plus 100. And that gave us 84 feet. That will be again negative 16 times 1. The answer will be negative 16 plus 100. 116 from 100 will give us 84. Now, s at 2 will give us negative 16 times 2 squared plus 100. So again, 2 squared will give us 4. And if we multiply 4 by negative 62 and we subtract it from 100, that will give us 36. So now we know the 84 feet and 36 feet at interval of 1 and 2. So now we can be able to find the SDT, which is our average velocity. So the SDT, we are using 36 minus 84. Remember 36, the time is 2. So it will be 2 minus 1. And that will give us negative 48 feet per second. Now next, we have interval between 1 to 1.5. We already know 1 is 84 feet. So we can find 1.5, which will give us 16, negative 16 times 1.5 squared plus 100. That gives us 64. So here we can find the ds dt, which is the average velocity. And it will give us 64 minus 84, 1.5 minus 1. We get 64 when we use 1.5 time, and we get 84 when we use 1. So it will be 1.5 minus 81. Or we can say 84 minus 64 divided by 1 minus 1.5. And that will give us negative 40 feet per second. Now, the next example, we have interval of 1 and 1.1. We already know 1 again. 1 is 84 feet. So we look for 1.1. So negative 16 times 1.1 squared plus 100 will give us 80.64. So ds dt will give us 80.64 minus 84. Now we use 1.1 to get 80.64 feet. So it will be 1.1 minus 1. And that gives us negative 33.6 feet per second. So here we should know that the average velocities are negative. all the three average velocities are negative. This indicates that the object is moving downward. Again, the object is moving downward. The object falls, so moving downward. Now, this will lead us to rate of change as a concept of finding first derivative if we are looking for the first rate of which is velocity. So in general, we say if s equal to s at t is the position function for an object moving along a straight line, then velocity of the object at time t is the first derivative of the function. Later, we are going to do the acceleration, which will be second derivative of the function. So here we say, in other words, the velocity function is the derivative of the position function. So velocity can be negative, 0, or positive. And also the speed of an object is the absolute value of its velocity. So speed can never be negative. So here we have the position of a free-falling object. We're neglecting the air resistance under the influence of gravity can be represented by the following equation: S at t equal to negative half gt squared plus VOT plus SO. This is again our position function. Here the S sub O will be the initial height of the object, and also V sub O will be the initial velocity of the object. Then G is the acceleration due to gravity. So on Earth, the value of G is approximately 32 feet per second, or 98.8 meters per second. This is a constant value. So we have a second example here using the derivative to find the velocity. Here we say at time t equal to 0 seconds, a diver jumps from platform diving board that is 32 feet. So from the diagram, we can see the height is 32 feet, the diving board above the water. Now, the initial velocity of the diver is 16 feet per second. When does the diver hit the water? And also, what is the diver's velocity at impact? So here we're going to use the concept of, again, derivative. But first, we can begin by writing an equation to represent the position of the diver. We are using the position function given above with g equal to 32 feet per second. Then the initial velocity v sub o equal to 16 feet per second. And SO, which is our initial distance, also will give us 32 feet. So we can write S at t equal to negative half gt, so it's 32 times t squared, plus VOT, which will be 16t, then plus SO, which will be 32. So again, we are using the formula here, position formula. So we plug in the value and we are going to get our answers minus 16t squared plus 16t plus 32. And this will be the position function. So from here, we said minus 62 squared plus 16t plus 32 equal to 0. So we are going to find the t when the diver hits the water. Now, when the diver hits the water, this means let x equal to 0, then we solve for t. So that's why we equate the equation to 0. If we hit the water, the distance is only 0. So here we evaluate this is a trinomial function. We know the common value is 16 among the three terms, so we take negative 16 out. And then t squared, here we have t squared plus t plus 2. We factorize it and we get t plus 1 and t minus 2. This is more or less like factorizing a trinomial. First, we find the common value, which is 16 among all the three terms. Then later we have t squared. Actually, we use negative 16. So we have t squared minus t minus 2. And that will give us t plus 1, t minus 2. We factorize it. So this means we are going to get the value of t, which is -1 or -2. Now we know that t cannot be a negative value. So t have to be greater than or equal to 0. So choose the positive value to conclude that the diver hit the water at t equal to 2 seconds. So in this case, we already said to find the velocity, we take the first derivative of the function. So the first derivative of the function here will give us minus 32t plus 16. 32 is 0. 16t, derivative of 16t will give us 16. Derivative of negative 16t squared will give you 2 times negative 16, will give us, again, negative 32t to the power 2 minus 1. So we get negative 32t, again, plus 16. So the velocity at the time, which is t equal to 2, we substitute 2 in our first derivative function. So s of 2 will give us minus 32 times 2 plus 16. So it will be negative 48 feet per second. We can see that in the first example, we find they gave us the interval of the time, and we were able to get the same value. So find the rate of change in terms of velocity. We can find the first value for the distance, then the second interval. Then we know velocity is distance over time. So the first distance for the time and the second distance with its time, we find the difference of the two. Or the best way to do this again is to find the first derivative of the function, again, for velocity. So that will be the conclusion of these lectures. In the future, we are going to cover how to find the second derivative of a function, and that will lead us to how to find acceleration. So again, wish everybody the best and take care.